Stream's up. We're up.
Stream.
Yeah, going live.
Alive. Live in the flesh.
We are. We is. And there's the wonderful music by Harris Heller. As always.
Waiting for it.
It's coming.
Yeah.
What do you got? It's there.
Yeah,
Happening now.
It's gotten already.
It's there. It's gotten. Oh boy, lots to talk about. Air mobility. Oh wait. Got one other thing.
Chat.
No, chat's up.
Yeah.
I have chat. Oh yeah. Woo! How you doing today?
Doing well. Yourself?
Doing okay.
Dry.
Because you have to.
Raining again.
Again, more rain.
Again.
Also raining trees from the guys. My next door neighbor's house cutting my trees. Not cool. Anyhow, we got so much to talk about today on the show. New graphics actually are completely worked out. All the new bugs are worked out. You ready to go? You ready? Ready?
Do
Except
it.
for- wait, I'm not.
Wait on Harris. Yeah. Hello, YouTube. How's it going today? Good to see you.
Because my beverage needed freshening up.
The beverage needed a refreshment. Hello, YouTube. Welcome to the show.
All right, here we go again. Ready?
Ready?
All right, let's do this. New graphics and all. Hope everybody pays attention to that. It took work. Wasn't easy. Sure.
Didn't just happen?
No, it didn't just happen. All right, we're gonna go. We're gonna 3, 2. Hey, welcome everybody.
Need a fade on that.
Nah, whatever it is. Yeah, we do need a fade on the music because the
How's it
music
going?
doesn't fade in or out. Hey, welcome everybody. Not Your Average Show. Mike and Corey here. It is July 1st, 2021. It is Thursday. We're in the studio. It's raining again. Yeah, again.
Yeah, I got people climbing in the trees.
They got people climbing in the trees, peeping Tom on us over here. But hey,
Chainsaws.
with chainsaws. We've got a bunch of information to discuss with you. We're going to follow up on a user request to look at the Chinese VTOL company EHang, which is going to be interestingly enough. And we also want to follow up on some of the discussions that we've had recently about what the challenges are that are going to face the flying car air taxi market in a series of videos that we've done. Looking at the air mobility or urban air mobility factor and the investors and the infrastructure that literally needs to be built and the players that are currently working on that, which is one of them is NASA and the FAA.
Yep.
Also going to look at one of the manufacturers that has jumped into the pool because a couple of people left comments out there about specific manufacturers jumping in and mixing in and what some of the useful ideas that are there. So we're going to take a look at Honeywell's contribution to that as well, because that's what's up on the market today. So what's going on with you, Corey? How are you?
Not much, man. Doing well. Yeah. Yeah, nothing really to report. Yeah.
Nothing to report. There you go.
We're dry today. No launch, but we're dry, so
That's a
that's
good thing.
always a positive. Yeah, nothing really.
And as if you may or may not notice, we have a couple of things. So the celebration that we have today is we have actually an exciting announcement, which is 250 subscribers, which is awesome
Yeah,
for
cool.
us.
Thanks.
The growth continues, which is thank you very much, everybody out there. Number one. Number two is we're introducing the new graphics, which has got our little globe, our information globe behind our logo, which is something we're kind of proud of. So some of the screen work that you see that normally we're part of the show, we're just adding new bits and pieces, and we're looking to bring in new graphics as well in the not too distant future. So that's something else to get excited about. But we do have other news in space. Now you want we didn't actually discuss who was going to introduce this one or just talk about it, but I guess we'll just flash it up there. Which is this is coming up right here. This is Mercury 13 legend Wally Funk, a female, will ride with Jeff Bezos to the edge of space. She's 82.
Yep.
Which is
Yeah,
Quite exciting.
she'll be the oldest astronaut
The oldest
when
astronaut.
she goes up. Yeah.
So basically, what this article here, this is from, who is this from? This is from The Verge, basically saying that it was
Verge.
announced by Jeff Bezos today that Wally, who was part of the early Mercury training program, she
Mercury
was
13,
the
yeah.
Mercury 13. She
Program,
was
yeah.
in there. She's waited a long time for this opportunity, and she's gonna go into space.
Yeah, she's flown a bunch of stuff. She's got like 19,000 flying hours.
Mhm.
She many of the tests she did when she was in training back during the Mercury 13 program, she did better on a lot of the tests, guys. So she was perfectly qualified, but it just never came to fruition. And that Mercury 13 program kind of didn't happen. It got closed down, and then she applied to the accepted female applications to regular astronaut program. She applied 3 times and never got in.
Mm-hmm.
So she's never been to space, but she was seemingly very qualified, as far as we could tell, and I mean, just never got the chance. So cool.
Yeah,
Yeah, it's
and
cool.
so interestingly enough, she did book a front row seat in a suborbital spaceship 2 from Virgin Galactic. So she's on board for that, I guess, too, to go into space. But now this is going to mark recognition for her and all of her achievements in aviation. And finally, at the age of, what was I said, 81 or 82, she's going to space.
Yep.
So good for
Yep.
her. So just
Very cool.
fantastic to see that someone's actually paying attention to the pioneers that actually put the Mercury program together, which
That's
made
really
a lot
cool,
of this
yeah.
possible for the U.S. astronauts. You know, we were in a huge space race with the Soviet Union for a long time. Mercury was key to that program and key to the people getting to the moon and Apollo and everything else that followed afterwards. And to see her get her return on investment of her time and energy and all that in aviation, fantastic. So, and I'm a huge supporter of women in aviation because my wife is still flying today. So, hats off to all the women in aviation, and thank you for your continued support in the
Yes,
industry
very
and
good.
everything you do, because you make it better for us.
Right.
So there you go. So congratulations to Wally Funk.
Congrats. Yes.
Hats off. If we were wearing hats, we'd take them off. Anyhow,
Why not?
hey,
Yeah.
take off the hat.
Yep.
All right, so we got so much more to discuss. So I guess the first thing we have to do is where we started this conversation the other day was the challenges that are facing the air taxi / flying car market in the not too distant future. And we said that a lot of them are basically waiting on the administrators or airspace FAA guidance on what it's going to take these things from either the manned position to the unmanned position, and how they're going to design the airspace and the intricate parts that are necessary to get what they're going to call urban air mobility, which is basically just what it sounds like, which is urban air mobility. And as that really stands, how does that really, I guess, translate to the average public? Because the average public really doesn't understand, I guess, what urban air mobility means. And it's just that. It means, how are you going to get from point A to point B in the air using the technologies that they currently have in place, and what's going to be part of that development?
In a city setting, yeah.
Right.
So obviously, yeah. I mean, many people watching. Of course, you guys have probably flown on planes, but jets, travel in through various national airspace system. But it's very well planned out and managed quite well now that they've been doing it a while, of course. And so there's airspace set up just for those corridors for those places. So now that we are on the evolving field of air taxis, and as it would be drones, unmanned or manned vehicles, but in cities, low level, the need to address that as far as regulatory and safety aspect is here. So this is what Mike's talking about.
Yeah.
So yeah.
So NASA basically, in this article coming to you from the Vanderbilt School of Engineering, says that NASA's got a $2.5 million project on their test bed right now, which is looking at the development of testing the safety of these air taxis. Now, when we talk about safety, we talk about threat and air management. We don't want to talk over people's heads, because there's a lot of discussion that has to happen about what really comes into the very minute points of safety. It comes down to very fine details. So we don't want to overbore you with that, but in a simplification manner, what ends up happening is anything that's basically flying has to be concerned about, well, its destination, how long it's going to take to get there, and when it gets there, what environment it's going to find in that surroundings, right? How's the weather going to be? What obstacles are going to be? What's the wind conditions? Okay, what's the landing site going to look like? Those are all variables that need to be figured out. And in an urban environment, when things are flying, it gets a lot more complicated because there's a lot more things technically to hit. And a lot more interference from other things. So when we have complicated electronics on board these aircraft, there's also going to be more cellular traffic. There's going to be probably more infrared from like security systems. There's probably going to be more Wi-Fi repeaters and all sorts of different things are going to be included in that. And when one of these devices is flying, it's not as easy as just putting it up there because it's going to have to think on its own on what to avoid as far as obstacles, weather, and environment. And that presents a challenge because, as Corey can kind of tell you right now, the minute you have something airborne and it has to turn in a different direction, and there might be other things flying around it, that creates a systemic problem where everybody else has to react to what it's doing, right?
Yeah.
Yeah.
Yeah. I mean, of course. Yeah. Yeah. It's
That's a handoff that he didn't
it's
expect.
it's yeah. I mean, of course, but yes, as Mike's saying, there the fact that these aircraft will be operating just again low level in a city, that's just an environment that aviation, in terms of, like big commuter jets, it's not quite the same, right? They
Right.
operate in Class Alpha airspace. That's where they usually cruise, and Class Alpha is quite high, starts at like 18,000 feet above the surface, or well, rather above sea level, but there you go, 18,000 feet. And so it's just a different place, and they need to address that. Many, as we talked about before on the channel too, with the technology really coming along at a nice speed, evolving, and with many different players, and we we cover almost a new one almost weekly. It almost we haven't talked about yet. There's a lot going on in there. A lot of players with government entities, NASA's involved, and we'll get. There's just a lot of things sorted out before it really hits prime time, and that's just assets of if this is gonna actually work, So,
hmm
um, yeah, what do you got up there? You got the one?
Well, I'm just playing
Yeah,
up in the background. NASA
yeah.
is just showing some of the competitors that are in this marketplace. And look,
Oh,
the vehicle
Airbus, yeah.
design is one thing, which is fantastic that these vehicles are being designed with the capabilities of transporting people short distances using either electricity or APUs or some sort of device. But this vast infrastructure of all these moving parts, it's critical. It's critical for them to get it right. They can't really just tinker with this. The testing and the flow of how this is all going to work has to be in place because should there be any difficulties, these devices, should they experience power failures or should they experience any sort of mishaps, bird strikes, so on and so forth, they're going to have to make the determination of when it's safe to continue, when it's impractical to continue, and when it's going to be a desired aircraft state to be back on the ground as fast as possible. Now, each one of these devices, with their multiple propellers or multiple propulsion devices, are going to have different variable, I guess, situations and how far they can continue into undesired aircraft states, meaning a power plant failure, a complete plant failure, which means it's an immediate landing. And it's going to have to diagnose how to assess and avoid those risks, right? So, this is part of the air mobility package because all that's going to have to be baked into either the person flying it and their ability to interact with the technology that's on board the aircraft, or the automated systems that are on board that are going to have to decide kind of on the go what's happened and how to react. And so Corey and I, when we taught a lot of people how to fly helicopters, we always had to speak in terms of, are we going to land immediately, land as soon as practical, or continue on and labor on with whatever's happening, knowing that it's a nuisance, but can we make it to our destination? And what would you say that the skills that are required that need to be, well, innate to the human being that you're training and to the systems that are going to be on board that are going to need to make those decisions?
Yeah, so one thing we would try to emphasize to people we are to fly when encountering an undesired aircraft state, and we'll just talk in plain terms. I won't use all the terms setting the criteria, but if you can imagine for a second you were in the aircraft with one of us and we're flying along, give you a practice scenario malfunctioning. We would initially give that to you, maybe verbally or something like that. So part of that, and then you'd have to think about like what does that mean to me? What kind of impact does it have on the flight? And then you need to act or react to that. But I don't want to discount the very beginning of that, and that was the detect. You have to detect the problem to begin with. So one of the thing, if you're a person on board, you have to not only see all the gauges and maybe even listen to the noises that are normal and all that, but you have to detect anything that's abnormal, whether it's a gauge or a warning light or a caution light or some noise. I mean, there's quite a large number of things that could kind of clue you into something that's not quite right.
Hmm.
And that certainly goes along with things that want to be flying automated, right? If you're talking about a system be flying itself around and you're gonna have to program in some logic, whether it's neural net or onboard or it's process somewhere else, we'll get to that. It has to detect be able to detect all the things that could. So that's one of the first things too. You got to detect that, but then also you have to be
Hmm.
able to interpret that accurately, know actually what you're looking at. And that goes a bit into just knowledge. And of course, a lot of the engineers you see our videos playing. This is, I think, the NASA still. So
Hmm.
it's quite a lot of knowledge that they're going in there. But it's something to know that when you teach a human to obviously detect and interpret, and then figure out what maybe the scenarios they can go with, and then choose one, and then act on that. That's a chain of events that now we're trying to get to do the same thing, and there's a lot of hurdles that can arise there that may not seem
There's a big one too.
apparent in the beginning. So
Yeah.
it's as they do a lot of the testing to see how we can get automation. They have to meld not only the technology and the logic of what you want to do with that technology, decision making
Well,
or
it's even
contingency.
yeah, because it's great when everything works, but you have to also design the system for when it's at failure, right?
Yeah, yeah,
So when the system's at failure, it's going to have to go into some sort of mode, like maybe a limp mode, where basically it's going to decide, hey, I can't make it to my destination now, so I only have maybe 7 minutes of opportunity to find a safe landing spot, right? And look, unfortunately, aviation's riddled with bad decision making by pilots, okay, that have
yeah.
continued on and stressed themselves into situations where it unfortunately didn't pan out. And that's a long chain of events that took place because it generally didn't start with that one decision to continue. It generally started with maybe poor planning or someplace else down the line. So these devices are going to have to be critical in thinking that before they even leave the surface, they're going to have a plan for action. And like Corey said, when we're actually teaching people things that are in the actual aircraft, we're looking for their decision making ability. But a lot of times that decision making ability starts even before you got yourself into that environment. So some of these systems are going to be so elaborate that these devices, before they take off, are going to probably have to making call outs to other weather stations, making call outs to the surrounding area to find out what other traffic is in the environment. It's going to find or have to discover new pathways to communicate when it's actually discovered itself in a position where it's about to fail, has failed, or what its next action is going to be to recover from the failure. And as you stack more of these urban air mobility transports around, they're all going to have to react in some sort of neural net technology where this one has experienced a failure, but there's 7 or 8 of them behind it. Now, what are they going to do if this thing has to, I'd say, turn back into the wind? That's because it needs to be wind facing, or
Yeah, who knows?
there's power lines and it can't maintain the same altitude that it could earlier, so now it has to turn in a different direction.
Could even say I was also that goes right along with what Mike's saying. If we were to say that along the pathway of the flight, there's like designated landing areas that
Hmm.
things can go if something goes not great with the public, that there's designated landing areas in case something goes wrong.
Right.
But nevertheless, where I'm going with this is if one of the aircraft that's airborne decides it needs to land and it takes that spot. Okay, good. Now they've landed. Everything's good. They're safe. Great. But now that means if somebody else in the other aircraft has a problem, that landing spot's not.
Nope.
So, um, on some level, what I think Mike's going to is they're gonna have to be able to communicate with each other,
Yes.
whether that's through a ground-based station or the vehicles to them within themselves or both. Um, and
Sure.
one of the manufacturers we'll get to later.
So anyhow, in the development of all this, so this is just a description of what the entire system has to do, and in order for you to successfully place more people in the flying general public in these urban, air taxi environments, right? So what does that look like? It looks like you trying to merge onto a very busy highway, okay? In your car, there's lots of traffic. You're pushing forward to get in line with that traffic, and everyone else around you has to react. And suddenly, in the middle of the road, you blow your tire. That's the best analogy I can give you is to that this system has to have that amount of fluidity in it to take on not only the expected, the unexpected, but the flow of traffic, right? So with that, there's also NASA's research. You can actually find these links in the description below.
Yep.
NASA.gov has this, which is their Advanced Air Mobility National Campaign, which is also working with their AAM ecosystem and working groups. Okay. And they all have these collaborative enterprises that are looking at how to integrate all these pieces. Okay. And it's fantastic. You guys can go in there and click on all this because this is what's going to really develop the top down look at how the future is going to handle air taxis and air and flying cars.
Yeah.
They're literally having to build this infrastructure now so it's in place for the new developments when they happen in technology to push forward. But they're not the only ones playing in this field because as well as just, NASA, developers and of course like Jobby and everybody else, they have to figure out whether they're going to turn around and build their own onboard systems that are going to handle this,
Yeah.
or if they're going to outsource that flying technology to other companies. And like Corey and I have realized, others are really stepping up. Like, and then Corey can go ahead and talk about Honeywell here for a minute because they're also doing their job to shape the future by building these systems for us, right?
Yeah. Yeah. So if you're, so just move along to the next one. It's actually the Honeywell's website, and it's aerospace or aerospace.honeywell.com. So it's their aerospace Honeywell. And Honeywell does a bunch of things, but one thing they do, which if you're a pilot or know they make avionics, you've flown something, you might have Honeywell equipment somewhere on the aircraft. They do a bunch of different stuff, but focusing on this here, they've already made some partnerships. Honeywell itself has already made some partnerships with some companies we've already mentioned on the channel. Vertical Aerospace is down here. Pipistrel is down here. Faraday.
Faraday?
I don't know exactly how you say
Faradare?
that. Faraday, maybe.
I think.
And then the one we talked about yesterday, actually, Aviation is in here as well. So they've already making some partnerships to get the. It's probably a good business case for them too to be on the forefront of market. No there, but
hmm
it's kind of going to show that some of the bigger players in just the tech field, other than the manufacturers themselves of making the vehicles, are really trying to step forward and come up with some solutions for whether it's safety or technical inspections, other things. So yeah.
Yeah, so it looks like in part of their technologies and some of the things that they're looking at the passenger urban air mobility aircraft, and that's going to be actually the aircraft that you physically fly on. Vehicle management, meaning how is that vehicle going to manage itself? Fly by wire, which would indicate that if you
No
actually
surprise.
have a person on board flying it, that there has to be some sort of linkage between them and the aircraft. Now, normally in most aircraft that are out there today, there's push rods, hydraulics, there's usually a lot of equipment on board
Yep.
that physically links the controls. Airbus is notably one of the aircraft that's flying almost completely fly by wire. And where there's no physical link, it's literally you have a joystick and that actually simulates what you feel with the aircraft
Yep.
and then senses or sends all that transmitted data to the proper surfaces and moves them accordingly so the aircraft flies as it should when you move the stick. There's also detect and avoid, meaning that this thing has to have some sort of way, like using the LiDAR, using vision, using some sort of system where it can actually look forward and understand what's happening. Also detects future failures like a battery pack failure or an engine failure, something of that nature. Actuation, which I'm going to assume is actually moving the surfaces themselves.
Yeah. The
And then
actual,
show all, I'm not really sure about. But then also, they're very heavy into the propulsion, which is motor controllers, turbo generators, thermal management. Oh, actually, I guess it's show all for their actual.
yeah. It's just it's an interactive.
It's an
graphic,
interactive part.
So
I'm not sure what show.
I didn't. Yeah, I wasn't gonna bring it up, but yeah.
There you go ahead.
Just, yeah.
You get me on it,
Yeah.
right?
It's
And then,
just, yeah.
so that would also fall into people like Jetupterra, who has also announced that they have agreements with Honeywell, okay, for part of their propulsive units. So there's that one. I didn't know that one was interactive because I only read it
Yeah,
in my
yeah,
iPad.
they're the buttons there. You can actually, if you go back to it, you can cargo
Oh, really? Let's let's go ahead.
right
And,
there. It says passenger urban.
so it
Just go,
says
yeah, that one is also.
okay. So there's cargo, and
I
then
mean, yeah, obviously
Mhm.
they carry cargo, which we know, but then
There you go.
obviously with the air taxi sector.
So for autonomy, fly by wire. So yeah, so there's basically detect and avoid. So
Yeah.
there's their systems that are on board, their connectivity, which is going to be GPS,
Yep,
some sort of
satellite.
Wi-Fi signals, sat navs, things of that nature, right?
Yep.
All that's going to be in there. But then they have and down here and look, they have their avionics for urban air mobility. So they have the different parts of the systems that they're going to have, and they just show you different examples. So look, it's just a continuation of the conversation because it's not going to be that easy to make this jump. And why we said the other day in one of our videos, that this market really needs 10 years to mature because right now, even the experts are saying we're probably 10 years off from it actually maturing. So while Archer and Jobby and Lilium and all these guys are excited to bring their aircraft to market, If there's players that you see in the field that don't seem far as advanced, don't discount them at all because there's lots of opportunity. And I guess for us, the opportunity is how long do you wait and see for the market to really become saturated with so many players where they just say, okay, enough is enough, right?
Yeah, I mean, it'll be there's a few more facets to this that we'll get along with this. Like we're gonna talk about EHang in a minute.
Hmm.
And one of the things I was gonna mention, which I can just quickly put in here and on too, but was that for example, like EHang has an advantage there in China that they have a partnership with,
Yeah.
right? So they have a bit of an easier way in for do some testing and maybe
Right.
getting some certifications for locations of where to do things. So it's there's a lot of facets to who will have success here and who will not, and it might not even be the tech side. It could be
Right.
business cases. It could be funding. Right? There's a
Right.
lot of
Right.
SPACs going around. We've talked about that. A lot of people getting money from SPACs. So there's just a whole bunch of different ways that this could not work. And so the leaders in it now doesn't mean they're going to be leading in it. Right?
No, that's
So
true. That's true.
yeah,
And this, I guess this goes without saying. Look, in this country, or the way we partner up with the government's a little bit different because a lot of companies go the other route. And what it means to be maybe in bed with the government means that you have a military contract or something of
yeah,
that
yeah,
nature,
yeah.
right? So look, we know that other companies like Beta, we know they're actually developing those unmanned units in coercion with, I forget which.
Isn't Volocopter doing the
Volocopter might be doing
the
it,
Air Force?
and we know that Jet obviously they publicly stated that they're doing their testing in the anechoic chambers to see that
Yep,
they're viable
yep. They
in
mentioned
whatever the
that.
military's plans are for that. So that's another way for people to move in from the marketplace, which is make the old switch like helicopters did from the Vietnam
True.
era, which was
They were
start in
held
the
yeah,
military
military first.
and
Yeah.
then go to the general public. So there's lots of ways to look at a way to get into the marketplace. But if the infrastructure is sound, you have NASA, the FAA, and they finally put their workforce together,
Yep.
and you have the companies out there supporting that infrastructure, we hope. I guess I say we hope
Yeah, we hope
we'll
too.
we'll see these things flying within the next, I think, 5 to 10 years in a capacity where they're actually doing volume and they're actually turning a profit maybe 10 years from now. That's
Yeah.
what I think.
Yeah, I'm thinking as well, like Mike said, I think we'll see them and we'll see some form of it in 5 years.
Yeah.
And what I'm going with that is like maybe if you're in Georgia, let's just pull something. You might have a urban air mobility air taxi service in Atlanta or something,
Hmm.
right? That's intercity or
Yeah,
something.
yeah. That would make sense.
Wouldn't be everywhere yet. So I'm thinking 5 years to see something in place that's doing some business, and then 10 years if it's something that's gonna be something that is proven to be profitable, right? Because money drives almost.
Right.
Then within 10 years you'd see it more widespread, of course.
Sure. Yeah. I mean, and hey, remember, folks, thanks to the 250 subscribers. And just want to say this as a caveat at the end. We are paying attention to this market specifically for three reasons. Number one, the investment dollars that are going into this market right now is enormous
It's explode.
and it's exploding up through multiple players. Okay, it's not just one, two. Yes, we've started discussions with Jet Terra, all this other stuff, but there's billions and billions of dollars at stake at this marketplace. It deserves the attention of some serious introspection from not only the people that are going to provide the services for the pilots, but for the manufacturers, for the equipment manufacturers. It's a massive marketplace.
Supply chain, everybody makes
Yeah,
power plants, avionics,
yeah.
batteries, all
Okay.
that's
It's
being forward to this.
Yeah.
Yeah.
Number two, it is probably at the forefront of the use of multiple technologies that people are finding on their everyday usage charts, like cellular technology, GPS technology, LiDAR, which is making its way into vehicles, as we've discussed recently,
Yep. Yep.
visual camera systems that Corey has in his Tesla.
Yep.
So this is going to be a complete integration of all these systems in probably some of the most fascinating technology combinations that we've seen since probably going to the moon.
So yeah, us being techies and pilots, kind of interesting.
Yeah.
kind
So
of to sum it up.
it kind of sum it up. It so it's kind of, and the third thing is there's money to be made.
Oh,
Okay. There's no hiding in the fact that if we could become part of that conversation as a whole, that's something that would be tempting towards us because that's something that we would just normally talk about anyhow.
yeah, that like we said on the channel. Right, I'm petting the dog if we can. Dog
Mhm.
here. But like we said many times on this channel, we talked about things before we even had a YouTube channel, we talked about
Yeah.
stuff like this, cars, technology, aviation. And this was honestly was before Airtaxis were even a thing
Yeah, yeah.
in its current form.
Because we could see them coming.
Yeah,
We saw them
we
coming.
talked about it and we're like, okay, but and now we got a channel. We're talking about this stuff with you guys because we're happy to still talk about it, and it's cool that you guys are interested.
Yeah, and so I guess it's interesting when you're sitting in the controls of a helicopter and you know at some point that even this technology has to advance because look, the form and the shape of a
Yes,
helicopter
said
hasn't
that too.
changed in a long time, right? And we were always sitting there going, look, some of these airframes we were flying are almost decades old
Yeah,
and 40 and 50 years
yeah,
old.
very cool to fly helicopters, but when you realize some of the ones they do were designed, maybe not
Yeah.
that particular airframe, but literally designed in the 50s, you're
Yes.
going, this is cool, and the things you can do with it have great utility. But I'm really curious where the next step in technology
Sure.
goes. Like what?
Yeah, go ahead.
There's got to be
Finish
something
the
newer.
thought.
Yeah, there's got to be something newer than this
Right?
that we can do. So when is that gonna happen? And
And it just
we might be on the verge of changes here. We know evolutions versus revolutions. We'll
mhm,
see how this really plays out.
mhm.
But we're super excited anyway.
And the last part was drones. When I started flying
Mhm.
helicopters, if you wanted to put together a drone, you had to literally go to a hobby store,
Yep.
build a frame, get 4 motors,
Yep.
find a speed controller, battery packs,
Yeah.
put them together. 4 years later, DJI and other manufacturers changed that entire game, and today they're almost looked as recreational toys. We do have more stuff coming out on drones that we're going to talk about later on next week, which is about all this trust information and what size and the legalities because hey, you could get yourself in a lot of trouble real easy. But
Yeah.
so that's kind of also a lead into the next subject, which Corey is going to hit it off right here about. We someone out in chat decided that it was really important for us to pay attention to one company that we really weren't, and that was
Sure.
EHang. And as a result, we started to do our digging, and as we dug more and more and more, we were intrigued because we knew they were out there. But I'll let Corey take it from there.
Yeah. Sure. So the next one, as Mike kind of lead it, had somebody at one of our comments saying, "Hey guys, can you take a look at EHang or what about EHang?" So EHang is one we had on our radar. We haven't really focused on it before that they've done, but just this segment's a little bit more. So if you're not familiar, well, here we go. It's a company that's done smaller size drones for a while. It's out of China, and they are now involved in doing larger urban air mobility vehicles, and they're actually making some pretty good inroads. So basically, EHang they've conducted basically flight tests in different environments, including they say in a typhoon. So that's kind of cool. Okay.
In a
And
typhoon.
numerous public demonstrations. They're going to Hong Kong. They're in China, or well, yeah, China. Did some stuff in Japan, stuff in Korea. So they're trying to spread out again, and see and kind of make some influence over there. And they're in the certification phase.
Hmm.
So they've already done flight testing. They've got multiple models. We'll talk models. They got a shorter range one called the now I say it's the 216, but what is
The
it? The
216,
EH216. Yeah, the EH216. It's more like a quad, or well, not quad. It's got more than 4 motors, but it's more like that kind of setup where
right?
it's all like there's a
Right,
vehicle in the
right.
middle, and then it has the rotors around the outside. And then they have one called the VT30, and that is their longer range. They can use it for some cargo as well. Intra-city. They're talking something in the range of 300 kilometers for that
Hmm.
one. About 100 minutes of flight, that kind of thing too. So, and that's also electric, right? So they've got some different things going on there. I is on.
I'm just actually there's a picture here, and I just have to talk about this for a second.
Okay,
So
sure.
this is the 216 that showed in the picture, and it
Yep.
showed actually going just about over Midtown Manhattan. The reason why I know because that's where my old office building was. However, what they do have pictured here right now is they have heliports on the roofs of the buildings, but somebody must have forgot that it's still illegal to land on the roof of a building in New York City. So that's one thing.
Never let. That's details, Mike.
That's details, right? So
Details.
they're really looking forward to the future because that's just happening. But this is the
Yeah, there it is.
216. Yeah. I'm just gonna bring up another vision here of the 216. So
That is it.
that is it's tiny. I mean,
It is.
it's basically a
Two-seater.
two-seater drone,
Two-seater.
right?
It's got rotors. You can see on
Hmm.
I think there's 8, or what is it? Is there one, two, three, four,
Quite a few.
8? But I mean, there's 2, right? There's one on
Hmm.
the top, one on the bottom. That probably helps with a bit with efficiency, but also they could probably run them a bit slower,
Right.
so they don't need as much noise. Possibly, I'm kind of a bit of speculation there.
Right.
And some of the things I've seen, they say about 150 meters as it's flying over the crowd, 86, 87 decibels.
Mm-hmm.
So again, something you would notice, but not obscenely loud.
That's pretty loud, though.
I mean, it's loud.
It's loud.
It's
That's,
loud.
I mean,
a busy city, 60 to 70 decibels, so it's loud.
it's that buzzing loud, though. It's that
yeah.
like the
It's
like
a drone.
it's a
It's a
bee loud.
drone,
It's buzzing.
Sound.
Right.
So really no surprise there with the smaller rotors, as we've said before in other things. We know to cover the same amount of lift area you might need, like a helicopter blade speed. If you're gonna generate that same amount of lift blade, you need to either spin them faster, which you may not be able to do, or have a bunch more of them.
Right.
We got a whole bunch more here. But yeah, out of there,
More is
35 kilometers a range with max payload. So short range, right? Not talking very far. 130 kilometers, and they say in 220 kilograms of payload. So basically two people, not too large. I don't know if you have the video or the picture there, but the arms fold up.
They do.
The arms all fold up, and it fits in a bit smaller space. One thing we were talking about just earlier, I don't know, do you want to go into how it communicates with base?
Yeah, right now I'm just showing some videos of the high maneuvering test flights, the things that they've put up. So
the other vehicles.
Yeah, so they're testing in Typhoon Force 8, I guess they said it. I mean, look, so I guess we just have to acknowledge, number one, they actually do have flying prototypes. Number two, they've had people on board.
Yep.
Okay,
Yep,
so
they've been manned. Yep.
And they have made those massive inroads. Okay, they might not have, like you said, the resistance that there is because the infrastructure in China, they're just kind of flying drones and they don't have a ton of infrastructure at this moment. But we don't know, particularly what it is. But it looks like, for the most part, they're ahead of the game. However, I will say this: they're not quite. What's the word I'm looking for? They're not unique enough more than just basically a high value DJI kind of design with people put on top of it. I mean, let's face it, they're not really breaking any ground here and what's happening in the development, but they're using that to their advantage because they're perfecting what's basically already in existence and using that to move forward, right?
Yep. Yeah, exactly. And so, I mean, evolution,
right?
Evolution of technology usage. Doesn't mean it doesn't have a place. We're not saying that for sure. They're already doing some things over there, and we know this market is expanding, like we mentioned before. It's air taxis is something the public is becoming more warmed up to.
Right.
That was one of the other things we mentioned before. You can have all these devices flying around, but if people don't, have the ambition or the on board, not gonna go anywhere.
Not gonna go over
physically and literally, right? But so people are warming up to that, and it seems also that in China this company is well received as far as what they're trying to do. So yeah, we'll lead to be seen what how far they can stretch and
right,
and how it goes for them. Really, I'm interested to see their solutions when they actually get operational. They're actually doing work. How their solutions to battery recharge or battery swap, like what are they actually going to do? What's the real world range with two people on board? With an actual job. Hey, you want to go 40 miles, or you know what I mean? Go a distance that way.
Right.
How far it's going to take, and then turnaround time because it's a business now.
That's a little louder than I wanted. Hold
on. We'll watch the video here.
We'll just go
further.
I'll be quiet.
Now, our goal is to improve urban public transportation and make urban commuting safer, greener, and more efficient.
Hold on, let's make this a little bigger. There you go.
Bam.
We have all the technologies.
EHang's autonomous aerial vehicles are safe and stable aircraft that are essential for urban air mobility.
Oh, yeah.
They do not require extensive flight experience. The future is here today.
Now, this music is better. The other music was worse before.
It's something totally different when you fly over the lake really high up, and it's great. I really loved it.
真的是特别的荣幸，也很幸运因为我是第一个在城市之间乘坐一航216出行的人。
Taking the airspace into use is fantastic potential, both for transporting goods and then also eventually people.
EHang's AAVs have unique features that differentiate them from other proposed urban air mobility solutions. Their full redundancy systems are continuously optimized to be able to respond to different situations and keep passengers safe. Furthermore, the autopilot of the AAV can provide passengers with a relaxing, stress-free flight experience powered by clean energy. The modularized EHang E-Port supports a complete automatic circulation system. Just like a transportation hub for more traditional transportation methods, like trains and airplanes. Neither runway nor ground space are required for aerial vehicles to take off and land. With this system, traffic circulation is greatly improved. This is an innovative new approach to managing traffic and minimizing congestion within urban areas.
That's a lot of infrastructure to put into a building. To
That looks really cool, but
yeah, that's a lot.
Inside the E-Port,
but
the
they're looking
conveyor
at,
as well as the parking
volume.
bots
Yeah.
keep the system
I
running
won't talk over the
smoothly.
video too much, but this is straight volume. There's the battery I was talking about that they could just swap out. Oh no, I'm sorry.
That's a mobility
I'm sorry.
device.
That's the thing that moves it around.
AAVs can be transported to different areas automatically for berthing, charging, and
I
maintenance.
guess so.
And can be called to vertiports for the next flight.
That's a lot of infrastructure for the volume of flying that they're looking at. I mean, that's a ton of infrastructure. This is to build one of these looks like it could probably take 10 years. One of these
The building?
Yeah.
It's looks very efficient once built.
In CGI.
But what's the range again?
Yeah,
You're gonna have crazy volume for a range of, well, what did they say, 40 kilometers?
40 kilometers, which isn't, you know,
EHang's
you're going to have 20 of these
also
things.
enables point-to-point flights or
35
urban routes. Managed by trained pilots, it is a highly intelligent backstage control center that coordinates vehicle dispatch,
And this is that
ground
infrastructure
planning,
that we're
and
talking
about.
safety
If they
for
ever need
EHang
a real pilot to take
AAVs
over,
to
they have that
ensure that
ability with
every
this.
flight
Yeah.
is completed
That's
smoothly and safely. For us, innovation means helping people get from point A to point B faster, more comfortably, and more sustainably. In the near future, this system will work for every one of us. EHang AAVs will become an
Unless you don't
essential
like
part of
flying
our
as a
daily
vehicle.
life, flying us into the
Well,
future
Some
of
people
urban air
are-
mobility.
Fly it anyway.
Right.
Well, there are people that don't want to get on jets, and
So this is just basically exploring the idea of what the urban air mobility will be for the future, right? And look, so we show you that, and we don't mean to make fun of their
no, not
their
making-
objectives and what they're going to do.
yeah.
That's an elaborate view for the future. That's massive infrastructure. So it's going to take a lot to put that into place. So I imagine that the first few e-ports that they're going to build won't have these, fancy machines and robots that move everything for you. It's going to be like 6 of these things on one side of town and 6 on the other. And they're basically going to do crisscrossing flights from 8 o'clock in the morning till 10 o'clock in the morning. Then they're going to sit and recharge. And then you're going to probably start up again at 4 till 6. And it's going to run something like that until they prove that it's going to be viable, right?
Brad says, did you say the noise level is 60? No, what I saw was that if the vehicle, they actually had a vehicle with people on board and it was flying above a crowd for demonstration purposes, decibel level when it was flying above the crowd at 150 meters was 86 decibels, about 586. So mid 80s flying above you, urban environment probably.
All right, so basically, let's take a look at some things that might be 80 decibels. So 80 decibels will be something like a garbage disposal, a dishwasher, average factory, freight train at 15 meters, a car wash at 20 feet, propeller plane flying over at 1,000 feet, diesel truck at 40 miles an hour. So it's not arbitrarily.
loud, right?
It's not loud, but it's not going to be quiet either. So let's just say it's it's not going to be like, oh my god, this is super loud, but it's going to be like you put 10 of them overhead though.
Yeah.
10 of them overhead.
A motorcycle at 25 feet. No,
Yeah.
That's pretty hard to judge.
Yeah, they are.
Yeah, as you say, garbage disposal, average factory. So freight train at 15 meters.
Okay, so here's my thing. So if you look at this chart again, right, you look at what's at 100 decibels, and that is a Bell J2 helicopter at 100 feet. Okay, so here's the difference, right? I could imagine that if you get 3 of these in a line flying in an urban environment, it might get a little annoying. You'd have to probably space them out so you're not getting one every 3 minutes to the point where it's like just a constant drone
And that is
blades, right?
That is a valid point to bring up, because being pilots, we fly in a lot of airports, and invariably at airports, at your home base airport, you hear about local
Noise abatement.
Yep. Well, any airport you go, gonna have those procedures, but your local airport where you land and take off from, communication with ops people there, and invariably we always have some area lives in the area that is not happy that they're flying over, and you could just imagine, as us, we look at, I need to fly, it's my job, fine, but you can imagine if your house was at the end of a runway, and planes are taking off and landing basically all day long, you might
a little
have an opinion about that.
Yes.
So just and what we're bringing up with this, the urban air mobility, is the volume at which these companies wish to operate in the urban space. Well, like you said, has a valid concern to noise and the route they go, not just for possible landing areas needed, but also it might be something that the more operations that would take place would be in like the more business centers,
right?
And then any the residential areas, there'd be ops through, or they have to fly over parks and stuff. We'll just have to see.
Or over highways.
Yeah, over highways where there's already noise expected, let's say.
When we talk about IFR, sometimes it's not, flying in the intrameteorological conditions. It's also I follow roads, because in many cases, if you're in a noise abatement area, they do have you fly directly over a road and then make late turns, and especially for helicopters, because they are notoriously louder than, say, your average Cessna. And even though sometimes a Cessna could be equal sized, if not smaller, a helicopter generally puts out almost, I'd say on average 20 decibels, if not more, at these same levels, because the way that they fly.
And the nature of the beast too. If you have an airplane coming in an airport, they'll have a lot of times 1,000-foot heavy. The final pattern for a GA flight, you'd be 1,000 feet.
Right.
To avoid any conflict with traffic, a lot of times they'll have helicopters, which are the more maneuverable, come in lower, so your helicopter's flying over an airport. If you airports and helicopters flying over real low, 500, 400 feet, maybe less, depending where they're going on the airfield. So they're loud. They're loud.
Now, it goes without saying, in Manhattan right now, there's very strict noise abatement rules for helicopter tours taking out of the South Street Seaport area for those tours, right? And other places do follow suit with that. So noise will always be a factor when these things start to contribute to the mobility of human beings in urban areas. Hey, we're out of time. I'm out of time. You're out of time. Yeah. We appreciate you guys tuning in today. Thank you so much. We again like, subscribe, and follow. And the other part of it is that we're appreciative of the 250 subscribers. Thanks so much. The channel is growing. We have Corey's going to be on a partial vacation next week, so we don't know what the actual schedule is going to look like yet. So we'll kind of keep you guys informed. Look forward to the comments on the YouTube page. Yep. I don't want to do this, but I might have to start a Twitter and Instagram to keep people informed about what's going on with the channel. But if it keeps you guys better informed about times and when you can show up for a show, we might have to do that. But thanks again for the participation, Brad, for the questions.
Yes, thank you.
And everybody have a very wonderful, great, safe 4th of July, and enjoy. Yeah, be safe.
Have fun, stay safe. Just be smart. Don't do anything have permanent damage. And we'll leave it at that.
There you go.
We'll leave it at that.
That's the best way to leave it. Everything intact. All right, everybody. We'll see you soon. Take care.
Take it easy.
Have a good weekend.
Bye.
Peace.
Gosh, we still don't have Harris coming in here.
I just got to create another one that's just called The Out. That's it.
Out.
The Out.
True.
Hey, guess what? It stopped raining, though.
on the way.
Yeah, great. Thanks, guys.
But yeah, no, it's yeah, I'm excited to see. Like we say every time, man. Talk about air taxis. Excited to see what happens. It'll be a different world. Well, for any reason, but a different world in the decade.
No, I had to. Yes. Anyhow, we're taking off. See you, everybody. All right, we're out of here.
Bye-bye.
Bye-bye.